Hello everyone, this is a presentation on the layering design technique for Software Engineering 1 at BYU-Idaho. This presentation was made by Kevin Matos and myself, CJ Wayseth. So, what is the layering design technique? The layering design technique is a way to design software into multiple layers, where each one only interacts with the layers directly adjacent to it in the full stack. This allows you to put specific code into specific layers and separate different actions and interactions between the user and the software, or between the software itself. In addition, each layer provides a service to the layer above it, meaning that the layer above will call down to the layer below to perform an action that it can't perform itself. The layering design technique can also be referred to as the layered architecture design pattern, or anything similar to that, like the layered architecture pattern, stuff like that. And there is no limit to, nor predefined number of, how many layers a software program can have. While there are a few common layers that most people use, you can have as many layers as you need to fulfill the requirements of your program. So here's an example of a basic layered design. You can see the different layers that make up the whole design, what each one does, and how they interact with one another. You have the interface layer, which wraps access to the logic of your program. The process layer, which implements business logic that involves multiple domain classes or even other process classes. The domain layer, which implements concepts pertinent to the business domain, such as like student or seminar, objects like that, focusing on the data aspects of the business objects, plus behaviors specific to individual objects. The persistence layer encapsulates the capability to store, retrieve, and delete objects or data permanently without revealing details of the underlying storage technology. The system layer that provides operating system specific functionality for the application, and the data sources layer, which is where the database is located. This could be utilized for book stash by creating an interface that the user will like, which will connect to our domain for the users and books since they are pertinent to the business. The domain layer will connect to the persistence layer, and that down to the database to record changes to a user's collection of books. And the system layer would relate to the browser that is being used to access the web application. So here are some of the benefits, pros, and advantages of using the layering design technique. The testing aspect of it allows for verification of every single part of your program. You could write code that can test the limits of all of the code that you already have to make sure parameters are passing correctly, as well as ensuring that there is cohesion between event sequences. Ideally, if the application is split up into its proper layers, it is expected that the program would be able to run without it being all completely written. This is one way to check for flexibility. For instance, if a calculator program is layered in this way, and you only have one of the four basic operations working, subtraction, for example, then you should be able to run numbers through the application and use the subtraction operation without worrying about not having made methods that handle any other operation. Similarly, code that is more layered could result in many more methods and steps to execute a certain action. However, it is also a way to make sure that data is only being manipulated when it needs to be touched. Lastly, if everything in your application exists separately from each other, then you should be able to rewrite every method if it would be necessary, because then you could do so without worrying about breaking a completely separate part of your application. Because the idea of layering your application means a lot more distinct functions and classes being presented in your code, this means there will be a lot more code being written. This isn't something you can really avoid if you want to make everything modular. So while it may be great from a design point of view, it is very time-consuming in its execution. However, you could argue that this time is saved through debugging. Next, some layering architectures, such as the microkernel architectural pattern, has you use a specific API, which might not always fit every circumstance that you have. So you have to know which design architecture to use for your specific program. Another unavoidable problem with layering your application comes in the form of event-driven programming. Depending on how you split up your program, you might have to write a lot of testing to ensure that you are triggering every possible event to make certain parts of your code run, as they would not always run in a normal user experience. Another way to view it is, imagine if you are working at a bank as a teller. If someone comes in asking to speak with a mortgage specialist, you can give them an appointment with that specialist. You would hope that the bank has hired good specialists that are prepared for the many kinds of questions that the client might have. But for you as a teller, and likewise if you were a client, when you walk into the bank that day, you know nothing about that specialist until they are actually called upon to do something. Imagine if this specialist needs to get client data to a server to validate some credit checks, but the server is down. Again, you wouldn't know this unless an event happens where this specific circumstance occurs. This also shows how there can be many points of failure in multi-layered code, because it means you have to test at many different points and with many different events in mind, so as to ensure that every possibility runs before your application reaches anywhere near the final stages of its design and testing. So our recommendations, what we think is the best approach for Bookstash, the application that's being made for our class, is the layered architectural pattern. It's great because it's already what most developers use. The idea of being able to split up the application into several layers also means that with a team as big as our class, everyone could work on separate parts, whether it's specifically the preliminary design or the actual code implementation. This layering approach could have the 5 following layers to it, including presentation, application, business, persistence, and database. The very bottom level to this would be the database layer, with the highest level being the presentation layer. The idea is that the consumer will clearly see the presentation layer, that is to say, the UI and their interaction with the application, but they will never see the bottom layer, which would be everything related to the database that keeps track of the books and all other data in the application. Although everything will be split up as such, it is important to note that the layers somewhat hinge on each other. Problems with the database layer may result in problems with the presentation layer, such as displaying incorrect, incomplete, or missing data on the screen, although it would still be displaying. Therefore, a lot of attention would go to the lower layers, especially so that the top layers can function properly. These were some of the references that we used for our presentation. And thank you so much for watching. I hope you guys learned a lot about the layering design technique, and hope you enjoyed our presentation. Thank you so much.